should probably jump right into our next presentation, which is Design Automated Equipment and Robot Cells in Minutes, presented by Vention's Jeremy Andrews. Jeremy, I will turn things over to you.
All right, perfect. Just double checking you guys can hear me.
Yep, we're good.
All right, sounds good. So I'm actually going to start off by sharing my screen. I have a short PowerPoint presentation, and we'll then jump into an actual live demo of using Machine Builder, which is our design software. As said, my name is Jeremy Andrews, and I am the user education and community lead here at Vencion. I started Vencion around 3 years ago as an application specialist, where I was using our design software, Machine Builder, day in and day out to design automated systems for over 300 plus clients globally. These ranged in industries from the automotive to aerospace, defense, medical, food and beverage, and quite a few others. And really, this experience using the design software as well as our simulation and programming software, Machine Logic, day in, day out, really ties closely to my current role as an educator here in Vencion. Now, throughout the rest of this presentation, I will be covering primarily a little bit about what Vencion is, who we are, what we do, as well as the design software Machine Builder. So for a quick introduction about what I will be covering. So obviously, I'll be covering what Vencion is, as well as the Manufacturing Automation Platform, or MAP for short. From there, I'll do a deep dive into machine building, explaining how it is essentially the fastest way to design and order factory equipment. And finally, do a platform demo showcasing Machine Builder. I'll be finishing off, like the other presentations, with a Q&A period if you do have any questions throughout the presentation. So to start off, what is Vencion? What is our mission and vision? So essentially, Vencion's mission is to democratize industrial automation with an online-first self-serve platform that enables high-mix manufacturers to automate their factory floor with confidence. So obviously, I did just read the slide there, so I'm going to elaborate a little bit what that means. So first, by self-serve, we mean that our users, primarily manufacturing practitioners, can design, automate, order, and deploy by themselves without the need for any external help. For example, going to third-party integrators or having to rely on external companies. The idea is that we enable people to do the designing and the automating by themselves. By high-mix manufacturers, we mean manufacturers usually with small production volumes that historically could not afford to have a profitable industrial automation installed in their facility. It's always possible to do it, but doesn't mean that it will actually return on their investment. And finally, with confidence, this means that essentially whatever happens online, essentially whatever you design within the cloud, we give a guarantee that before our users commit to any kind of investment, that it will translate one-to-one to their factory floor afterwards. Now, just quick Vencion by the numbers. So Vencion was founded in 2016, which means that in July, in a short few months, we will be coming up on our 7th year anniversary. We have 3 offices currently, one in Montreal, Quebec, Canada, one in Berlin, Germany, and one in Boston in the United States. We have over 14,000 machines currently deployed in the field, and we serve over 3,000 clients across North America and Europe. Now, for the slide over here, I'll be sharing a little bit of the standard journey of automation. So obviously, before moving on, I want to share the journey that I'm sure many of you are accustomed to and can relate to, which is the standard process of implementing industrial automation in your facility. So normally, you start off with, say, a statement of work that defines the requirements for the project. That once it's understood and a direction has been set, you move on to selecting the automation components that will be required for this. Looking on distributor websites, praying and hoping that there might be a 3D model or two that you can then import into your own CAD software. After you've selected all the parts that already exist, you then have to use your own 3D software, say CATIA, AutoCAD, SolidWorks. There's quite a few of them out there, to design the custom components that will be used to actually integrate the parts from the suppliers. From there, for all the custom parts that you have to create 2D drawings for them, create your bill of materials, including all the fasteners, making sure that everything is in that nice itemized list, and finally get supplier quotes for all these things that have to be manufactured to make your system function. At the same time, if you're going towards a fully automated system that will have automation in it and controls, you'll then have to talk to your electrical engineers. If you don't have electrical engineers in-house, you have to search externally to find someone that is able to build and develop the PLC that will then run your system. Once that's figured out, you can actually then launch the manufacturing of the custom parts, have them ordered, and then have everything arrive at your facility. From there, assemble everything, put it together, test it, make sure it functions, and have your factory acceptance test. From there, disassemble everything, ship it over to your client site, reassemble it for the site acceptance test. So this is something that our founder and CEO, Etienne Lacroix, is extremely well versed in due to his time working as an engineer at GE here in Montreal. At GE, he got the experience. He got to experience the huge process. That this is a huge process that really can take months to complete, as most of the tasks done here are something purely manual. That the work really does shift from one environment to another, and then one has to move data from one environment to another. So for example, you're going to be looking at suppliers' websites, then you're moving over to your design software to design custom components, and you're talking with suppliers, having to then download and share with them the 3D models. You're working with Excel spreadsheets for your bill of materials, using timeline, Asana for the timeline management, et cetera. There's quite a few different softwares that you have to do just to complete one single project. So he essentially came to the realization that there's nothing more manual than actually implementing industrial automation. And really, this is how Vention came to be. He saw this problem or this issue that essentially implementing industrial automation takes between 2 to 4 months, depending on the project size, can even take more in some cases. And he wanted to fix this, to make this a much more enjoyable experience, something that removes a lot of those pain points. And that's essentially what started the creation of Vention. So Vention, we like to call ourselves essentially a manufacturing automation platform, or MAP for short. That our goal is to enable self-serve industrial automation through an end-to-end digital experience. So Vention essentially is built upon 4 main pillars. So what we have in these 4 pillars is the design one, which is centered around our design software machine builder, where users get to design with what we like to call essentially industrial Lego. It's an environment where Vention actually owns all the geometric data and metadata of every single one of the parts, including the price, the weight, the item description, and more. So with all of this data, all the data sets, we can do a huge amount of software automation that normally wouldn't be possible with traditional CAD software. I'll be showing a little bit of what this automation is, but this includes, automatically generating the bill of materials, automatically updating the price live as you're going through it, ensuring the parts compatibility so there's no guesswork as you are building your system. From there, you move on to the second pillar, which is the automation side. So once you're done designing using Machine Builder, users can actually program their machines via a visual sequence editor, VSE for short, where you can program your machine in a code-free environment and actually simulate it directly within the cloud. If you're satisfied with your system at this point, you can move on to our third pillar, which is the order. So Vention has tried to make the ordering process as easy and seamless as possible, emulating other e-commerce sites such as Amazon. You can add a design to your cart and simply check out. You can add simple parts to your cart and check out, have it delivered directly to your shop floor, or if it's more of a home project, directly to your house as well. Finally, for the deploying side is that users will receive their equipment in IKEA-style packaging, very professionally packed, to make sure that there are no damages along the way in transit, so that it can all be assembled using a single tool, essentially. So now, since Vention controls both the hardware and the software ecosystem, we ensure that the project from the ideation to final deployment is accomplished seamlessly. So really, depending on the type of project you're doing, be it a range extender, custom workstations, can be accomplished from the design conceptualization phase to actually receiving it at your door in as little as 3 days, again, depending on the application. So wanted to share here, there you go, a little bit of the machines that exist out there using Vention. So for those of you that haven't seen or heard of Vention, you might have seen some more Vention Blue, be it at trade shows, events, client sites. But I really, in this slide, really want to share with you to check out all the cool machines that have been deployed in the field using Vention. And really the common denominator for each of these is that they've all been designed, they're all custom machines designed using Vention's platform. So each of these, we didn't have to go to SolidWorks, we didn't have to go to third-party providers to find some additional parts to make the systems function. It's all designed using hardware directly available on our platform. That each is unique in its own way, which speaks to the beauty of the MAP platform as a whole. So the system really allows you to move really fast on your automation projects while keeping a lot of the flexibility due to the modularity of the system. So really a lot of our hardware is designed around an aluminum extrusion ecosystem. So the final thing that I do want to touch on before moving on to Machine Builder is the application side of Vention. So applications, pardon me, are something that live on top of our platform. So obviously right now we provide users with an exhaustive toolbox for them to create their own custom system using Machine Builder, Machine Logic, Machine Cloud, quite a few different offerings that Vention has. However, we have gone ahead and grouped some of our hardware as well as our software kits that have defined functions into application grouping. So these applications can include palletizing, bin picking, conveying, gantry robots, range extenders, and really quite a bit more. What this does is that it provides users with a pre-made solution that have been both field and software tested with a proven track record at client sites. So as of right now, I believe we have around 18 different application categories, but as Vention progresses and matures, we release new ones throughout the year. Now, to get into the meat of what the presentation is over here is Machine Builder. So essentially, we like to say that Machine Builder is the fastest and easiest way to design and order factory equipment. It's obviously easy to say that, but what I'm going to do is actually have the software speak for itself to showcase how easy it is to actually design automated systems or industrial structures. In this final slide over here, it just shows some of these smart design features and some of these smart design tools that Machine Builder has integrated into the software, including, say, a validation checker, some tooltips as you're designing, as well as a library of more than 1,000+ parts, fully modular to make it a complete ecosystem. But some of this I will be touching on in the live demo. So for the moment, I'll move on. So now for the platform demo. Again, if there's any questions, you can ask them in the Q&A section, and we'll most likely get to them after the platform demo. So with this, I will change screens over here so you can see the Vention website. So as I said, there are multiple pillars. You have the designing, the automating, order, and deploy. I'll be focusing on the design pillar of Vention to showcase how easy it is and how powerful it is as a tool to use when designing automated systems. And we're getting here. So to get started, if you do have an account on Vention, to get started with your first design, all you have to do is find this nice green button over here and click on Design Now. From here, you can input the design name that you'd really like to have. So for example, I can do a webinar demo. Select the application category. Say I'm working on designing a case packer or some gantry robots or a range extender. It does help categorize the designs in your own design portfolio if you do get to a number where they do get a little bit harder to manage. From there, you can input a description about the project itself, but a lot of this information can actually be edited at a later time, so you don't have to put all the information right from the get-go. And then finally, you have the users. So one of the great things about Vention is that you can actually collaborate on designs simultaneously. So you don't have to have one person in charge of the entire design process. You can have multiple colleagues or teammates working on it at the same time and saving their own versions as you go along. I'll be showcasing a little bit how that can work. But for the moment, get started, you simply click on Start Designing and it will load you directly into the software. One of the great things about this is that it is entirely free to use up until the point of purchase of your design. So everything you're seeing me do on screen here is something that everyone on the call can do by themselves. So in this case, I already do have a design already open for the purpose of this that I will be demoing and showcasing some of the great features of Machine Builder. The application itself is a machine tending application for a CNC. So we have a safety enclosure around here, 2 part presenters, a range extender, and a CNC model in here. You will notice that there are some unfinished aspects of this design that I'll be doing or demoing as we go along, such as completing the safety enclosure, some misaligned extrusions over here, some straight missing extrusions, as well as maybe editing the range extender, so editing the automation components live directly within the software. Now, before I get to that, I want to do a little bit of a tour of the user interface over here. So if this is your first time using CAD software, some of this might be a little new to you. However, if you are used to using CAD software, like I said, CATIA, SolidWorks, AutoCAD, Creo, Onshape, you'll see a lot of similarities. The one thing I like to highlight is that Vention acts much more like an assembler than an actual custom design tool. So we have a catalog of parts that we have on the left that you then, bring into your design and design with, as opposed to, say, designing a brand new item or a brand new tool from the ground up. So starting with the UI discovery a little bit. So in the top toolbar over here, we have a lot of the design tools that you will be using throughout your time in Machine Builder. This includes, our measurement tools, the ability to change between metric and imperial. So for those of you that are used to using metric, we do have a system built out in millimeters. If you're used to using imperial, we do have the ability to show in inches. One thing to be aware of is that our ecosystem is built around a 45 millimeter increment. So it is recommended to design in millimeters if possible. From there, you have the ability to change how you view the system, exploded view, which is great for the assembly process of your system and seeing how it looks if you're looking for a bit more detail within it. The other two features, or the rest of the features, I'll be highlighting a little bit more as I go along throughout the demonstration, but they are similar tools that you'll see throughout other CAD softwares. Now going over to the left side over here, you'll see the name. So as I created this, I called this one essentially a design engineering webinar, but you do have the ability to edit this name and edit quite a bit of other data if you like to, say, update the thumbnails of it, link this to a scope of work, as well as the ability to share this and download some assembly instructions. Other useful tools, you have the standard save icon, the bill of materials that I will be touching on later on in the webinar, revision management, where you can actually see who has edited what at what point, and the ability to take some thumbnails. Now, for those of you that are a little bit used to using different design softwares, Vention has made it a little bit more easy for you to get accustomed to this one. So if you go to the menu, click on settings, you're actually able to change the default mouse settings to some of the larger, more prominent CAD softwares. For myself, I've been using Vention for about 3.5 years now, so I've gotten accustomed to using the Vention default. So we'll be sticking with that. Other than that, we do have quite a few smart design features in this. So these are great for people that are getting up and running with their first automated system. And I would recommend leaving them on, such as the automatic part suggestion and the configuration assistant. I'll be showcasing how it works a little bit later. The final thing that I want to touch on in the menus is under help, which is the keyboard shortcuts. So Vention does have quite a few keyboard shortcuts built into the software to make, again, designing a little bit easier. Some of these shortcuts are the standard ones that you'll find across the board, say using Google Docs, Google Slides, Microsoft Word, such as Control-C, Control-V to copy and paste, Control-Z and Control-Y to redo and undo, but does have a few extra ones designed specifically for Vention, such as the ability to recenter your design, hide and isolate parts, as well as, resize and reinsert parts. Again, some of these I will be touching on as I go through. So that's a little bit of the UI discovery. The last thing that I want to touch on is the parts library. So this is where, as a designer, you'd be spending a lot of your time looking through the parts that we have. So it acts similar to a parts catalog, except the main difference is after you select a part, you don't have to then download a step file, then upload it into the software to make sure that's the right one. If you realize you've downloaded the wrong size of profile, you don't have to delete it or resize it or use some parameters such as in SolidWorks to resize it to what you need. It's all done for you. So to showcase how easy it is to use, I'll just drag over to some empty space over here and say I want to make a rectangle in space. All I have to do is select the extrusion profile that I want to have. And let's drop it into space right over here and drop it into space. So we call ourselves essentially a click and click interface for designing. So you simply click a first time and then click a second time to actually drop it into space. And that's how easy it is to add new parts to the design. So what I'll be doing now is actually moving over to design to see what we have to do to finish this off to showcase some of the great features. So starting off with the enclosure over here. So you'll see I have quite a bit of other hardware in my design already. I have the part presenters, the range extender, as well as some more of the fencing in the background. So it gets a little bit harder to design with all that in the background as things might try to snap to that instead of to the extrusion that you're looking or targeting to. So what we can do is actually highlight one of the first shortcuts, which is the ability to isolate parts or hide other parts. So in this case, say I want to work solely on this section over here. I can highlight it, then press Control-J to isolate that part of my design. With this, any work that I've done here is reflected in my design, and the rest of my design does not actually get deleted, simply gets hidden from view and I'm not able to interact with it until I bring it back. So for now, let's finish off this part of my enclosure. So first thing I see is I'm missing a top extrusion over here to close it off. So in my case, I do know what length that what I need to add here, which is the length of 1170. Simply select that from the drop-down menu, bring it in and attach it to the location, or bring it to the location I'm trying to attach it to. The way this software works is that it will give you the most likely orientation that you're looking to attach your part to. I'll show you guys how this works as I bring in the plating over here. But you'll see with this, I attach it, say I attach it at the wrong location. So I can undo over here, grab my place again. Say I attached it over here, realize it's at the wrong location. I don't have to delete the part, bring it back in, re-import. I can simply click on it and using the available degrees of freedom, actually just slide it up to where I need it to be. With that, it is a constrained part. Now what I'm missing is some of the plating over here. And this is where I'll highlight some of the great design features or the smart design features that this system has. So I have a T-plate over here with 5 different holes. That means I have 5 different connection points at any point along my extrusion. In this case, I know I want to have the T-plate facing down the same way that I have it over here. The system actually gives you or proposes the most likely use case for that part in usually the first, second, or third orientation of the part placement. Again, I can cycle through using my arrow keys on my keyboard or on screen to cycle through the orientations, but again, the most likely proposed one is the first one. So I can confirm by clicking on screen. And here, let's see over here. Over here, you'll see one of the smart design tools that we have, which is the part suggestion. So normally after clicking a part, it gives you a part suggestion of the second or the third, fourth, fifth most likely used parts after this. In my case, I'm looking for a specific part to lay across this, so it's not going to be offered here. But say when designing those plates, again, the most likely next part you're looking for is one of our aluminum extrusion profiles. So in this case, I'm looking for a 1x5 plate. So I go back to my parts library, find the 1x5, and drop it in plates. Again, I have 5 different locations that this can connect to, and not an infinite amount, but a huge amount of different options or permutations for the placement of this. But in this case, it automatically guesses that I'm looking to have even spacing and even attachment points on either side. So with that, it completes the framing of this. I'm just missing a little bit of extra hardware. So here I'm missing a leveling, or essentially one of our floor anchors. This allows me to show a little bit more of the discovery of the parts that we have in our library. So if I go over to the frame accessories part, you can scroll down, see that we have quite a bit of other hardware. We have aluminum extrusion end caps, we have rest pads, bumpers, drawer slides, hinges, door frame accessories such as door latches, and then finally down here, the floor anchor. Again, simply snapping in the exacting configuration that I really most likely wanted to attach in. Save that there. Now it looks like we're missing one final component, which is the panel that slots inside. Obviously, it's not a safety enclosure unless you are actually fully enclosed. So Vention actually has a panel generator built directly into our software. So there's no more required to, figuring out the dimensions that you're looking for, going into or opening a new design file, creating the panel with those features, then adding all the holes manually, making sure it's the right thickness, the right panel material, then finding a supplier for that panel. This is all done for you by Vention. All we have to do is really design or find the location you want to build the panel. So in this case, I want to have it slotted in between these 4 extrusions. Select all of them, right click, create panel. In my case, we have quite a few different panels that we can use. I'm looking for the polycarbonate, which is the see-through panel, and selecting inside. I believe at outside, you'll see that it automatically generates, seems like I've confirmed the outside, automatically confirms or adds the required fasteners to attach it to your structure. So what it's doing right now is actually creating the panel. You'll see it did just appear in the design, and then it's loading in all of the fasteners for it to actually attach it to my structure. And right here, this is one of the newest features that we've actually implemented is the ability to add custom cutouts. So over here, you'll notice that it actually did already create the automatic cutouts around the plates that I have in my system. But in my case, I want to showcase some of the slotted ones. So I'll actually go back over here. So see, we have the automatically generated cutouts. Delete the panel, reselect them, and regenerate my panel inside. With this, once I click create, it won't offer up the exact same options because it'll be perfectly slotted inside, so it won't need any fasteners. You'll see if I zoom in on the side over here, it is designed in such a way that it rests directly within the aluminum extrusion without having to do any extra cuts on your side. So now that I'm finished with my system over here, I can bring everything back into the design space by pressing Control-Shift-H. So again, you'll see that I did not actually lose anything in my design space. Now, another great shortcut that I use throughout my time as an application specialist designing is the shortcuts R and F. So what this does is it recenters your design and then full screens everything that's in your design space. So say you're working on the bottom of your range extender and get a little bit flipped around, rather than having to rotate over and over to try to get to the proper angle, you simply click R to recenter the design in your design space, and F to full screen everything that you have in your design. Now, the next step that I want to do is actually finish up working on the two part presenters over here. So again, I'll press the top view and use the shortcut showcased earlier, which is Control-J to isolate these two parts. Now let's look at the left one to see what I'm missing. So in this case, it looks like it's mostly complete. The only thing that I'm missing or see that is wrong with this is the fact that this extrusion does not go all the way across. So therefore, if I try to assemble this, it's not going to really provide the proper bracing necessary for my part presenter. So there's a few different ways I can go about fixing this. The first is I can take this extrusion, delete it, go back to my parts library, structural and framing, select the correct length or measure the correct length, and then select it from the drop-down menu. However, one of the great shortcuts that is added as a smart design tool is the ability to resize your extrusions without having to delete them. So in this case, I can left click on it and using the shortcut L, or conversely selecting the extrusion, right clicking and selecting resize, allows me to then resize the extrusion directly within the software. Again, no need to delete, import a new profile, import a new step file into design, do all the mating surfaces. It's all done for you. And one thing you may have noticed as I've been designing is the price in the top right corner over here. So see that it is hovering on, $40,500. The reason being is quite a large enclosure with an automated system in there with a range extender. But you'll see as I'm doing these steps, so if I press Control-Z to undo this, notice the price does drop down. So each part, like I said, we have all of the metadata. So we have the part dimensions, the part weights, the part price. So as I change my design, the price actually updates live with every change that is being done. So if I confirm this, we'll see that the price did update to the 40,510. In this case, I'm going to press save to save my design and look over at this guy. So in this case, I'm missing an entire bar across. And this is a chance to show two great new features. Now that I'm done with this one, I don't really need to have it in my design space anymore. So what I can do is press Control-H to hide what I've selected. From here, I can go over to the system over here and select the part that I believe I might need. So in this case, again, I can go re-import aluminum extrusion or use one of the most used shortcuts on our platform, which is the letter I, which reinserts the last clicked part. So if I press I can simply reinsert the extrusion over here that is the correct length and just drag it over to the location that I need to attach to. Here is one of those locations where it did not give the right orientation on the first go, but I simply had to click the arrow twice to give the one that I was looking for. And with that, I've completed my part presenter and bring everything back into view and finish off my design by working on the range extender. This is where I'll be touching on the automated or the designing using automated systems in our software. So again, this one, I'm going to isolate it so I can focus on just the system. So you'll see over here, I have an enclosed timing belt. So on our platform, we have quite a few different linear actuators. If you look over into the linear motion section of the parts library, you'll see that we have our enclosed ball screws, enclosed lead screws, rack and pinion, belt racks, quite a few different actuators. In this case, I'm looking to have a robot, say something similar to a UR10, Doosan M1013, Fanuc CRX 10IA. So with that, I need a slightly more heavy duty actuator. So the one that I have here, which is a standard duty enclosed timing belt, really won't cut it. So what I'll do is I'll delete the actuator over here, which does leave behind a lot of the rest of the structure and actually import the one that I'm looking to have. So in this case, I do know that I need an actuator of 2,295 millimeters. So I take this and drop it into space to showcase one of the other great design features that we have. So moving this off to the side, you'll see we have a configuration assistant. What this does, it essentially tells you, hey, you need all of this hardware to make this automated system actually function in real life. So in this case, it tells you what motors are compatible with the system. So our medium and large servo stepper motors, the fact that you'll need at least 2 proximity sensors to act as the end, stop, and homing sensor, a controller, and an e-stop to make sure you actually have the safety and the power to control the system. Obviously in this, I already have all of the hardware there, so I can simply close this to skip that step. Now again, I can do the designing by actually dragging this over to my design, which is what I'll do to showcase again how easy it is to design with this software. So that I simply press confirm, and that's how easy it is to modify your designs to actually swap out some of your automated equipment in Machine Builder. Now, one of the last things I did want to showcase, let's bring everything back in, is a design tool or a design piece that is quite useful when you're designing more complex machines that I'll use for, say, this plate over here. So I'll delete this plate, reinsert it back into space over here. Say I have a quite complex system and I'm looking to edit this or attach this part, and the drag and drop or the click-to-click interface just isn't cutting it for the moment. We do have the ability to use a point-to-point connection, which allows you to select what point you're looking to connect, and then the secondary point of what you're trying to connect it to. Again, with this, it tries to propose the most likely orientation first, but I can cycle around them if I'd like to. Now let's go save. And with this, I'm going to show you the last 2 things that I really wanted to showcase for the software. This is a full package that you are getting when you are essentially signing up for the platform, which is free to do. First is the revision management. As you see, I am on version essentially 13.13. But if I go to my revision management, you can actually see as I was designing, the design was changing, I was iterating on it. And if I really wanted to, I can go back to any of these previous versions and start working from that one. Any work that I do is not lost as I design along, as long as I click save. Also, it mentions who the designer is for that specific version. In this case, I'll close this and showcase the last great feature of Machine Builder, which is the automatically generated bill of materials. So I did highlight the fact that we do have the BOM icon over here. Clicking this will open up a new link to the design page where I can click down to the bill of materials and see a line-by-line itemized list of every part that I have, the status of it in terms of the quantity that Divention has in stock, as well as the quantity of it in your design. So in my case, if I scroll down a little bit, I'll notice that I have, say, 4 aluminum extrusions that are 180 millimeters in length. I have 8 aluminum extrusions that are 765. The list really goes on to accommodate all of the parts that you have in design, including the panels that you have generated. Now, one of the great things about our software as you're designing is the fact you do not have to account for fasteners. See this plate over here? Again, I have 1, 2, 3, 4, 5 holes. It automatically accounts for the fact that, all right, this plate is attached to this type of aluminum extrusion. Therefore, I will require 5 fasteners and the 5 associated T-nuts to actually build it, assemble it in real life. So you don't have to do a little bit of that tedious work that is necessary, but does take up quite a bit of time in your designing process. So this essentially did a very quick showcase of what Machine Builder is, what we have to offer, and how it functions. So at the moment, I do have a few other things that I can showcase, but if there are any questions, I will open up the floor to have, essentially open up the floor to questions if anyone does have any that they would like to ask.
Awesome. Okay. I had a question about, does the application show like dimensions or constraints if you're testing out motion, like on the belt driven part of it?
Absolutely. So if I go over here to the top view, so the first thing, say if we're talking about dimensions, you do have the ability to actually automatically annotate everything. So say we want to see dimensions. This dimensions all of the aluminum extrusions that we have in the software. So if you're looking at a specific one, it tells you that this length here is 1170. You do have the ability to also show the prices of parts, but say we also have degrees of freedom in this. So as you saw, I did slide the aluminum extrusion over here up and down, say before I get to the automated system. Say for our door hinge, obviously we can slide it up and down, but you also have the ability to rotate the door. So goes you a degree of freedom for the door, and then to, I'd say, bring that home a little bit more, Isolate the range extender once again. So in the system, you do actually have the ability to drag the range extender gantry plate. So say if I had a robot attached to this, or a custom gantry or custom end of arm tool attached to this, I'd be able to actually move it along all within the same design space. To add an additional layer to this, if you go over to Machine Logic, say configure your entire system, you actually be able to simulate this in real time as well. Fortunately for now, I don't have the time to do this, but there are quite a few tutorial videos or showcase videos of this on our platform if you are curious to see that as well. One thing that I didn't touch on is the ability to actually design with robots directly in the platform. So we have quite a few different offerings such as Doosan, Fanuc, Universal Robots, Epson, Canova, and you actually have the ability to, once you do bring them into your design, place them in, and actually edit and manipulate the robots themselves. So everything that I'm doing here is not a admin mode, anything special. Anything that I'm doing on screen is something that you guys as a user are actually able to do yourself as well. So this allows you to do, some preliminary reach studies with your robots, or to see, hey, if I have an enclosure this large, can my robot potentially hit the enclosure as well? So long answer, but hopefully that did answer a little bit of that information that was asked.
Yeah, absolutely. Is it possible to bring in models from outside the Vention ecosystem? I noticed sort of the ghosted CNC machine, just to sort of give dimension and that kind of thing. Are they just sort of dumb or ghosted objects? Can they be integrated into a design? How does that?
Yeah, so I'd say that there's two answers, or there's two parts to that answer. The first, what you see over here in the CNC, is actually part of our public models. So on the left over here, public models, environmental. So this allows you to, bring some environmentals to set this up versus other systems. So for example, if you want to set this up, again, one of the great ones is an operator. So we have two different operators in our system, as well as various different, stock CNC models. However, say you are designing a jig around a specific part, so a fixture, you actually have the ability to import your own step files into the design. So going to My Models, you can select Import Parts and actually select your own file. Files are acceptable up to 200 megabytes, taking this down the standard step format. So step, SDP, solid part, IGS, cat part, and actually import that into your design and design around it. One additional piece of information: if you are used to using SolidWorks or third parties or different design software, you can actually download your entire design itself as a step file by going top right and exporting it and downloading it as a step file, and importing it into your own software. Vention tries to make it as easy to work with whatever workflow you're used to, but Vention tries to make our own workflow as easy as possible to do as well.
Gotcha. I know you guys are always improving and updating the software, and is there a way for users to report bugs if they, can you leverage them as beta testers in some way so that they can tell you, hey, I ran into this weird behavior?
Yeah,
Just
so obviously there is a few different things we can do. I'd say there's multiple different avenues. Do that first. Say you can request a design review and say, hey, I found this issue in my design. Second, if you are working on a design that happens to have a Vention collaborator, you can actually comment directly within the design. For example, over here, mention, hey, these parts too over here aren't connecting properly. Otherwise, if you're working on a design, you can actually say, let's go back to this design page and minimize the bill of materials here. You can actually leave comments on the designs as well, give feedback like, hey, these two parts of here I've had issue with. Otherwise, we do have a contact us page, but a lot of, say, the smaller bugs that you do find, we are actually able to, we do find them ourselves and are always in the work of improving and editing our software to make sure it does work as well as possible. But again, there are quite a few avenues. Like I said, comments in the design, comments on the design page, request design feedback, as well as an actual chat bubble over here. You can message over here. This is a chat that is actually being moderated live during standard work hours, if you have any additional feedback for us as well.
Great. You showed a lot of the assembly part of it. Is it possible? I mean, it was in addition to sort of being able to move a robot arm or the belt-driven actuator part of it around, are there ways of animating something or doing more engineering work, like a simulation of here's how this would work? And Does
Yeah,
it get
so
that?
absolutely. That is the second pillar that I mentioned earlier on in the presentation, the automate side. So you'll see over here we have 4 different tabs over on top. So you have machine scope, which you can actually scope out your entire project and have it linked to a design. Machine builder, which is the design environment that I'm in right now, and then machine logic is the one that you are actually referring to. This was, I'd say, not part of the initial demo, but I can actually showcase how easy it is to do. So
Sure.
machine logic is where you can actually program and simulate your system. So you can actually program linear actuators, rotary actuators, robots as well. So in this case, add an actuator, create an application. In this case, let's add a motion to move to home. So in this case, once I press play, you'll now see the actuator moving live in real time. So essentially what I did to program this was done right now in front of you. And I can then have this, say add a motion, move to a specific position of 500. So now the actuator will now move to home and then move to a position of 500 along its available travel. So obviously this is a very rudimentary demonstration of the simulation portion of this, but you can take this and expand it to having robots simulate directly within the cloud. And again, everything that you're seeing on screen here, there is no paywalls behind anything. The only time you have to essentially pay is when you want to buy the system.
Gotcha. And what is the third pillar? What's machine cloud?
So machine cloud, this is really when you actually have already purchased your design, it's a step-by-step walkthrough that helps you actually deploy your system. So it tells you, hey, when you receive your parts, this is what you should do first. You should unbox your systems, lay them out according to their part, size, dimension, and then being like, okay, you have the associated assembly drawings attached to it. You have your wiring diagram if you have an automated system attached to it. So it prevents you from having to search through different areas and different avenues, either on our website or externally, to help you build your system up. So it follows you step-by-step process of getting your system deployed from essentially a boxed, your boxes that receive on site to a up and running system. So right now, unfortunately, because it's a demo that I have, and I have not actually purchased this entire setup, it does remain grayed out. The only way that it is you gain access to it is if you do have a purchased design.
So people receive the flat packs, and each one would be numbered or lettered or identified in some way, and then there would be these step-by-step instructions: open this box, do
Yep,
this, kind of like an IKEA.
exactly. So that's like like I said earlier, like the predecessors in IKEA-like experience. Obviously, you are using industrial automation and industrial components, so just a little bit heavier and a little bit more sturdy than your standard IKEA furniture. But we do also offer an alternative to that, in that if you don't have the time to spend assembling all this. So if you see on the top right over here, if I do a drop down, it actually tells you the estimated time to get this system up and running. It's approximately 9.5 hours, or pardon me, 9.3 hours to assemble this entire system. If you don't have the manpower or the time to do this, Vention actually does offer pre-assembled services. So say you are buying a small workstation or buying a machine tending cart, we can actually ship this out to you fully pre-assembled. Obviously, there is a premium to that service, but it does take a lot of that time off your hands. You are receiving essentially a full solution at your door rather than that IKEA. Although some people prefer the IKEA because honestly, it's a lot of fun to do, building the systems and essentially being able to say, like, I was the one that built this from the ground up.
Gotcha. How many companies, how many suppliers are in the Vention ecosystem? Obviously, you guys have certain things that you are branded Vention, including the motion controller that's a part of your inventory, but there are also third parties that supply.
Yeah.
Yeah.
So off the top of my head, I won't be able to say,
Oh,
simply because we keep on adding them quite frequently,
sure.
but some of our major suppliers. So Vention isn't trying to reinvent the wheel for a lot of the the tried and true solutions. So for example, if I go over to our conveying systems, material handling, we have belt conveyors. So this is supplied by one of our partners, Dorner. We have the robots that we have in our platform, such as Fanuc, Doosan, Universal Robots, Epson, Canova. Some of the other systems, say if we go over to the safety controls here, safety over here, we have Datalogic and Keyence area scanners. So obviously Vention, anything that you see that has this like essentially beautiful blue Vention color is most likely a Vention designed Vention hardware that we take ownership of. But a lot of the parts that exist out there in the world, we're not trying to compete with everything there. We're trying to make it easier for you and your team to implement industrial automation. So the linear motion, those are mostly, or the vast majority, Vention hardware, but say some of the linear bearings, we do have suppliers for that. But again, unfortunately, top of my head, I don't have an exact number, but
Sure.
quite a few, definitely.
Gotcha. And like you say, more and more of them are being added all the time.
Exactly.
Gotcha.
Exactly.
Okay. Well, I think that's all the questions that we have. And thank you again, Jeremy. That was awesome.